Okay, wonderful. Well, thank you, Ebony. Thank you, TBD, for inviting us to present what we did with for this hackathon, which was, I believe, the sponsor was mainly the Decentralized Identity Foundation about a month and a half ago, and well, took this opportunity to explore more and force myself to really learn how decentralized web nodes work. I certainly had seen the specification from DIF themselves, but certainly having a concrete implementation and actually having uh, uh, APIs to interact with the DONs has made a huge difference into trying to really implement ideas about personal data stores. And so, yeah, this was great. We were lucky to win, and we're basically here to show you what we did. I will not go over the entire presentation again because there's actually a recording, but I will do a recap of the main points of it. And secondly, we're going to show how we have extended the application since then. I think it's very cool that we can actually use machine learning to consume decentralized web node data, and then discuss what's next for us. And lastly, I'll leave the well, of course, I let my teammate give her impressions in terms of the UI. She's a user experience expert, and then open the forum for any kind of questions that you might have. So with that in mind, so I'm going to go to the next slide, and just a reminder of why the current model, the Web 2.0 model, it really no longer works. And simply because the rewards are there for those people or those organizations that amass and centralize our data, right? So the incentives are not for the data producers, musicians, filmmakers, bloggers. It's very hard to get compensation through this model. But yet, the ones who amass and centralize and mine this data, they get to make a lot of money. And of course, we are actually feeding now our very sophisticated technologies with machine learning. We're feeding those models with the very own data we produce, and then we are more susceptible for preying, right? For example, think about Cambridge Analytica a couple of years ago, how through the power of social networks and, of course, mining people's information, how they were able to affect and effect election results. And that was, very just the beginning of it. Now, of course, with large language models and the ability to really tailor marketing campaigns and very targeted messages to the individual, it is very scary what that can be done, because they're mining on our very own data, and we have no say on it. And hopefully this graphic displays how the model currently works, where, the little me on the left, on the bottom left, and on the top, the boxes just represent my digital interactions with government, taxes, DMV, even health information, the COVID issues. And then finance, an example is mint.com, and how they centralize our financial transactions, they mine them. But what is worse, that mint.com was actually acquired by Intuit, which is a tax preparation software. And Intuit now has a view of not only how much you spend, but also how much you make and how much you pay in taxes. So they truly have a deeper understanding of your finances and, what you like to do, and your psychographics, where you spend it, what kind of magazines, so forth and so on. And then health, granted there's HIPAA compliances, but, insurance companies still are able to mine that information for their benefit. And then, of course, entertainment, YouTube, TikTok, all of that, how all of that is exploited to change our ideas, our beliefs. And on the bottom, all of that data gets aggregated by these data brokers, and they truly have a deep knowledge of little me. And so we all agree, what's the problem. So in terms of how can decentralization help is, the basic tenets or some of the attributes of privacy of decentralization technologies. We have privacy, we have consent, we have provenance, and there are many other attributes, but those attributes empower us to choose who we share our data with. And then, of course, because these are so disrupting, now it allows us, the decentralizers, to come up with new models of businesses that profit the data producers and no longer the centralizers. And the graphic, it's been changed so that, again, we have our digital interactions on the top, but I'm actually in front of all my data, and I get to choose who I share it with. And this, database icons on the bottom may very well be these decentralized web nodes where we can store any kind of information, streaming files, health data, financial transactions, and so forth. So for this idea, what are we doing? Well, we're leveraging decentralized nodes, which are based on open standards, to store personal financial data. And as I mentioned at the beginning, we are going to leverage machine learning simply because, we can store all the data that we want and keep it safe and then choose who we want to share it with. But the real value of our data and with our consent is to actually come up with insights and predictions through the magic of machine learning and make those models work for us rather than working for a central authority. So when we demo this application, so we were able to extract financial data through Plaid. I'll do the same thing today. We are able to store account and transaction data into the subscribers. Now I call, not the owners, but I call the subscribers dons. And we're able to view them, but mainly what I want to show you is how that data can be used by machine learning. I guess let me quickly go through a high-level architecture of what that will look like. I'll do the demo, and then I can talk about more of the little components in this demo. But we can see on the left our quintessential Alice and Bob dates and decentralized web nodes on the left, and how our application fits right in the middle. We are indeed becoming a broker, as if you will. But in this case, we leverage decentralized web nodes where we are just basically message relayers. We extract data through Plaid in their link bridge and simply push that information. It's just passed through into the corresponding owner's decentralized web node. The reason we also exist in the middle is that Plaid offers the ability to update the data through the use of webhooks. So it's not feasible that each decentralized web node is declared within the Plaid infrastructure. So essentially they would have, if things work well, they would have millions of subscribers within the Plaid infrastructure, and they could very well do it, right? I do become the middleman, but in this case, I am trying to provide value as long as the user or the subscriber consents to that. They could very well just remove my access control rights, my ACL permissions, and I no longer read their data. I no longer run machine learning processes on top of their data. And that is the beauty of Web5 or decentralized technologies, that really is up to the subscriber to choose who to share their data with and revoke that if they feel like I don't offer any value whatsoever. So on the bottom, actually, this was part of the original slide, but we never really went deeper. Today, my goal is to show you what is federated learning enclave is and the federated learning cluster. Let's see. Well, this might be beneficial to show you before, although it might be a little cryptic. But again, it's almost the same diagram, but we dive deeper to what this means in terms of federated learning. Where again, on the left, I have my decentralized web nodes. In the middle, like what I call the proxy, is really a pass-through service. that is able to read and write into anybody's decentralized web node. On the bottom now, Plaid, it took a lesser role, but still pushes the data through my proxy to everybody's decentralized web nodes. And then, of course, we have on the bottom left a UI to view those transactions. But most importantly, on the right now, we have what we call the federated learning enclave and the cluster and aggregation. And in the enclave, an agent is tightly coupled to a decentralized web node through its DID. But notice this tightly coupling is short-lived. Once the process ends in terms of training models and actually coming up with predictions and insights, the process can be killed, and therefore there's no risk of any data leakage. If you're familiar with federated learning frameworks, essentially models are processed against the data at the edge, but the data never really goes into some central database. The only thing that gets back to a global or centralized database is really just the trained models or the updated models, where they get collected in the cluster, they get aggregated, and they get saved, and the cycle continues on and on as more data is amassed in the decentralized web nodes. All right, so I think, it's time for show and tell. So I'm gonna go through a terminal just to make sure my services are running. So I have my proxies running. It's just a stateless decentralized web node service. And I love the fact that it's stateless, so this can be scaled at will and be able to handle, thousands, if not millions of requests with a proper elastic infrastructure. So I'm gonna go, I'm not gonna show you the federated learning part just yet, but I'm just gonna show you really quick what the improved UI looks like. I gotta shorten this and go back to here. So hopefully you can see my browser with a nice wallet. So I'm gonna get started with the OAuth flow, how I'm able to integrate Plaid into our application. We're gonna continue. I'm gonna choose Chase as my financial institution, continue through the login. This is again this is the sandbox environment for Plaid, so their UI is not very pretty, and their sample data is actually not very useful. So I'm able to choose my accounts. I'm able to select what data I share with my application. You will always read the terms and conditions, right? And it's doing the OAuth magic. So I'm getting an authentication token in return, which actually gets stored in the decentralized web node itself. I never centralize it. So if they don't want me, if the subscribers don't want our application to mine that data anymore, all they have to do is revoke the access to the auth token. All right, so something's got to happen. It's preparing loading accounts into decentralized. Cool. So that went through. In here, actually, the reason the screen is empty is because we have a synchronization issue, in which I wanted to bring this up with TBD, and of course, it's by design. Each subscriber in the browser has an in-memory embedded in the browser, the centralized web node. But notice my proxy actually wrote to, I'm actually going to show you this. I want to retrieve my decentralized, come on. Okay, didn't go through, sorry. I just want to grab my decentralized ID. And I have an ion window here to see where on my side tree, what my document looks like. Cool, so I have an embedded in browser, in memory, decentralized web node, but also those nodes are parked in these addresses, down 4 and down 5th, which are multi-tenant. But right now I have a synchronization issue, which is cool. I actually have a separate browser, which I already had stage, so you can see more or less what the data looks like. So Bank of America, my checking and my savings, all of them have their corresponding transactions. And of course, the UI is work in progress. I wanted to focus more on the machine learning aspect of it, but we know this can be improved. Certainly, it's low risk. Let me go back to, I grabbed a decentralized web node ID. I'm sorry. And I don't mean to confuse you with a lot of copying and pasting, but this is important. There's a reason why I'm doing this. This was my old did. I'm gonna paste this guy. I'm gonna go to Bob's. I also want to copy Bob's did as well. Okay. Where are you, did? Come on. Here it is. And again, there's a reason I want to do this, so bear with me. Here and copy the whole thing. Oh, come on. Come on, demo gods. All right. So going back to my main browser, did it refresh? Did the data sync? Let's see. Yes, it did. Okay. So notice Bob had Bank of America, whereas Alice had Chase. And again, I can see their transactions. So this is what we showed in the hackathon. And I guess just the idea of it was very neat to the judges. And well, I think it's cool. Certainly, I've been spending my time with web nodes, so I think it's very important that to prove that this actually worked, especially when it's integrating with a commercial package such as Plaid. But now the cool stuff begins now. If you recall this slide, I have an agent which I have to bind to Alice's web, and agent B that has to be bound to Bob's decentralized web node, and then I have my global models database in my cluster for machine learning. So just a caveat, notice that the data is really not significant to be able to train robust models. So really what I'm showing you here is more the integration and the infrastructure to communicate with decentralized web nodes. I'm really not showing you properly trained models because we need to bootstrap that data. But with that caveat in mind, so I'm gonna go here, start my database for machine learning models. I'm gonna start my aggregation and cluster service. And what I'm going to start next are what is meant to be the enclave for done agents, which eventually are gonna be short-lived to minimize the risk of data leakage. So I'm going to go to this window. I'm gonna paste this command. Notice it's Python, data scientists love Python. And actually through this exercise, I learned it and I kind of like it. It's very easy to do many things. So now here's the reason why I was pasting these dates. Notice they are different. So I'm gonna grab Alice's did. And I'm gonna paste it into here. And so essentially I'm running this agent labeled Alice, and I'm gonna bind it to this decentralized ID, which is going to do of course, the done resolving or the did document resolving, and I'll be able to extract the data itself. Boom. So it's running. This is my IP address. That's my assigned did, and voila. Now I'm able to see. Let's see, where's the good? I receive meaningful 8 financial transactions from the done. I'm gonna go to Bob's agent. I'm gonna copy and paste this command. I don't feel like typing all of this. And all I will do is actually copy Bob's data as well. And it's the same process, right? It's some resolving. Come on. paste PubState, boom. Voila, so I have a proper federated learning framework. This guy has 16 transactions. Cool. And notice that actually both agents are actually talking to my stateless decentralized web node service. And you can see it's dispatching my 8 transactions, my 16 transactions. And so models are being saved, global models are being saved back into my centralized database. My cluster aggregator is talking to my 2 agents for Alice and Bob. And yeah, I'm doing localized model training. I'm transferring the local models back to the cluster and basically making the global model robust. One thing that I missed was actually saving the local models back into the DON, which is now very feasible, and that can be a self-feeding and making the local models even more robust, which can then later be aggregated. So that's really what I wanted to show you. So let me know if you have questions, or if not, I will interrupt these services because my machine really is old. And Courtney, let me know if you want to say something in terms of the UI.
Yeah, thanks for bringing me on here. So essentially, not too much has changed in terms of the UI because, of course, the backend has a lot of time and work put into it, but it's already been exemplified in terms of how Plaid streamlines the onboard experience, where essentially with the web view experience, the aim for the design was to revolve around the central theme of choice, making sure that users are aware and have the autonomy to make the choice of whether or not they want their data to be shared. And with the onboarding experience, showing the message of what's being authenticated and what's being accepted, displays transparency for the user. And of course, we want to make sure the user's end has the trust that we need. And also with the transparency, it's just revisits the central theme of choice, making sure that they have the choice of what's authenticated and what is linked with their banking information. And with moving forward, once we have the backend established, the plan was to incorporate additional features into the application. So essentially, a channel factor budget creation experience where there's preset budgets, choice of customizing presets, or features to differentiate necessities and nice to haves. Those are essentially just some of the ideas that were presented in the hackathon, where again, going back to the choice of theme and making sure that the user has the autonomy to customize their own experience, while we also streamline everything in the back end to make sure that it is replicated and their data is not being infiltrated like um, other platforms would without any of that transparency in the beginning. But that's essentially it in terms of the user experience. And once we move forward with the backend, it's essentially open playing field with seeing what we can do with the user experience.
Absolutely. And I'm going to add to what Courtney was saying is that it's very important to actually get feedback. It's, although, we all think this is cool, but we don't know how much the market is ready for it. Particularly, we consumers, we are very, we're okay. Well, in general, we don't understand the implications of Web2 business models. So we don't really mind sharing our information. So there's a mind shift on how we do businesses with corporations that actually respect our privacy. So it is very important that we actually get feedback from who would be our customers. So that is part of what's next for us. Present, now that we have a proof of concept, so show it to key players, and where can we add value, right? So we need to have that designed mindset where we implement quick features, and we certainly need that feedback of whether they're acceptable by the market or not. We need to rethink it. And the idea is to not go one path, invest thousands or millions of dollars into features that nobody really will use. So the feedback is very important. So in terms of machine learning, we really want to partner with small community banks and credit unions who don't have the infrastructure to actually manage, statements and their customers' financial data. I think there are actually corporations. One is Jack Henry, which are in the business of serving these small community banks and credit unions and provide infrastructure. So in a way, we could try to replace systems such as Jack Henry themselves, and again, leverage decentralized web nodes to manage their customer financial data. Not only in terms of our business model, it's very important for partnerships, but also we need to access, as I showed you, these small data sets are really not enough to create robust machine learning models. So we really need to have access to anonymize. We don't need to know who owns what, but we do need to have access to those patterns to train our machine learning models. And being in terms of expanding offerings, being that this is a fintech, and I know TBD is basically sponsored by Block, which now they have this TBD exchange, and they want to make it seamless when it comes to using crypto or fiat for payments. These are very these are financial transactions, and they may very well be stored in our decentralized web nodes in our platform, and we can actually provide the same level of insights and predictions as regular banking transactions. So yeah, we're evaluating that. Again, Plaid also has these identity validation services, and we may very well be able to offer know your customer and verifiable credentials for identities. So that again, this is a green field. The opportunities right now are endless, and I'm pretty excited being in this field. Definitely working with decentralized web nodes. So with that, I'd like to see who has any questions.